Hello, my name is Tom Mahon from the Banetti team. I'm here to do some introductory information about the Maximo product line and asset management in general. This is the first in a four-part series to discuss the basics of what is asset management, why do our customers do asset management activities, what's the purpose in our business. From there we'll continue into what are the core Maximo products that have been around now for decades, that are very successful in the industry. How has that product been extended with industry solutions and add-ons? And how is it now evolving into the new Maximo application suite? But let's get started first in talking about asset management principles. What is an asset? Organizations, if you think about the purpose of a business or another entity, the purpose is to purchase assets, put those assets to use to create product, manufacturing, services, processing industries, government services. All sorts of organizations have assets that need to be maintained. So assets are the nouns of the world. They're the things that people use to get work done. When we talk about the asset management life cycle, there's a lot of different ways to present it, but I'm going to look at it from a holistic top-line view. First, you acquire assets. That's the purpose of the business, is to get assets and to put them to use. You have to commission those. Sometimes the commissioning process is very intensive, requires a lot of activities to get properly set up. Then you operate those assets to serve their intended purpose. And while they're operating, you may do some maintenance. You may have to do some repairs if they break. You may have to overhaul them at some point in their life cycle. And eventually, the organization will decide to dispose of assets that are no longer of use in their inventory. We talk about enterprise asset management. A couple different perspectives I want to delve into. First off, why do people do asset management programs? First and foremost, it's all about uptime. You put all those assets on a manufacturing floor, you want them to be working full time. You don't want them to be down. You lose money when assets are not working, or you miss the opportunity to make money. Either way, it costs a lot of money for many organizations. Total asset visibility is still very much a requirement for organizations today. You'll be surprised as you learn more about this business how many organizations don't have good visibility into what they own across all of their sites, and they don't have a consistent way to identify the assets that they do have, and they need to get there so that they can really get an understanding of what costs are driving their business. Operational effectiveness. We don't want assets that are down a significant percentage of their time. We want to increase their utilization. We want to increase the productivity of the workforce that's maintaining those assets by getting the right information in their hands at the right time. Supply chain. Assets require parts of various kinds and natures, from a simple filter and gaskets up to replacement motors, replacement engines in cars, all those kinds of things. You need to have the right products available to perform maintenance during the asset life cycle. And for many organizations, regulatory compliance is very, very critical. FDA and life sciences, aviation is managed by the FAA, Joint Commission on Healthcare. There's all sorts of organizations that are heavily regulated and need to document and show that their assets are performing correctly in order to deliver their intended mission. Another perspective that's very important when we look at asset management is the difference between the asset management capabilities of your ERP or financial system and your enterprise asset management system. Now, ERPs are very, very critical to a company's financial reporting, and I don't want to dismiss their importance at all, but it's a very, very different focus from what we do with your typical enterprise asset management activities. In asset accounting, a fixed assets module, for example, organizations are interested in a record of all of their capital assets. They normally put a floor under which they don't want to bother to keep track of things because it's not financially relevant to their reporting at the end of the year. Some places that's as low as $1,000 or $2,000 in some of the small public sector environment. Other places I've seen it as high as $250,000 or even $500,000 before an asset becomes part of the financial reporting for a large organization. Those transactions that are most important to the ERP are the acquisition cost, improvements or betterments, major impairments that reduce the asset's value, depreciation over time, financial depreciation, and then the disposal. So those are the transactions that hit the books on asset accounting. And the financial responsibility may be assigned at a department or a site level, so we get some sort of a cost allocation across the company. Again, very valuable information in the company's financial reporting. Now, the asset manager out in the plant, out in the field, is interested in all of the assets, the inventory it takes to manage, to keep those assets operational, the work associated with doing the maintenance and repair, procurement, safety, operational status of assets, all the inventory at all value levels, all subcomponent assets. Those are all considerations that the enterprise asset manager has to look at when they identify what assets are in the system. So where you may have 100 assets in your fixed assets, you may have 2,000 or 3,000 assets in your operational asset inventory. Your transactions do include the acquisition because you need to know what you got and where it's put and what it's going to be used for. Inspections, commissioning, disposal, maintenance, repair, and overhaul, all the supply chain transactions. We're interested in all of that detail, sometimes down to the penny level. Okay, and then the transactions here are the detailed costs associated with performing maintenance. Labor, materials, tools, and services are the general ones that we run into everywhere we go. And then the enterprise asset management system can either post those detailed transactions to the financial systems, or many times the EAM system is used as a sub-ledger to the financial system. So the only transactions that go across are postings in the general ledger as journal entries. Now, let's talk about some of the terminology here related to EAM: maintenance, repair, and overhaul. I like to break this down actually fairly simple. The lifecycle process, once an asset is on the ground, maintain, keep it running, make sure it's working properly, avoid downtime with simple things you can do on a typical preventive maintenance type of an activity. Repair, if it breaks, fix it as best you can, possibly replace it while it gets fixed, but perform a minor fix to the asset. At some point, you may decide that an asset needs to be overhauled. It's pretty much used up its life, and rather than trying to incrementally fix it and try to minimize downtime, we're going to just replace it for a while, take it off to a rebuild shop. Aircraft do that. Every so often, the engines get taken apart all the way down to the fan blade level. All the gasket screws and bolts get all put back together, and they overhaul it and essentially restart the life of the asset. Now, other drivers for asset management are programs like reliability-centered maintenance, where organizations are really trying to focus on a holistic view of what they do. Within the public sector in particular, we see standards called good state of repair. You'll find literature on total productive maintenance. There are ISO standards like ISO 55000 on asset management. Accounting standards that actually affect how you maintain assets and how decisions are made about asset reinvestment. Federal highway and transit regulations. Joint Commission works on healthcare, making sure that your hospital is maintained properly. ITIL standards and information technology. And there are literally thousands of published documents out there that organizations can look to decide how they're going to maintain the asset inventory that they have. One more perspective on the word enterprise in asset management. We frequently run into customers that have very disjointed strategies when it comes to asset management systems. They can have a different system for each different major class of assets. Their vehicles are in one system, the fleet system. They've got a facilities system. They've got an IT system. They've got a manufacturing maintenance system. All of these things are frequently in different systems. Our goal is to consolidate those. And when we do that, we have one set of interfaces to go to your financial system, your HR, your timekeeping, your supply chain, those types of things. We can do a robust set of capabilities across all the asset classes and make organizations much more efficient in their management and approach to these types of systems. Now, let's take this down to the next level. Those are the strategic context in which we operate. Let's take it down to the next steps to how do we actually do an asset management plan? First thing is know your assets. We want a complete inventory of all the assets that the organization is responsible for. And there's a set of data that's applicable to all assets. What's the asset number? Let's get a description, a serial number, manufacturer, model, acquisition costs and date. All that type of generic information is there across all assets. Decisions will be made on what's considered an asset and what's considered a consumable. And different organizations will address that differently when we get down deeper into the weeds on what's within an asset and what needs to be tracked as a separately managed item. But then we have to classify those assets. What we're looking for is how many air conditioners do we have as opposed to how many pumps in an oil processing facility. There are different sets of information required for those two different classes of assets, but we want to classify the assets so that we can start to analyze across a class of assets what types of things we need to do strategically to better run our operations, increase uptime, reduce maintenance costs, those types of things. And then assets go into locations. An operating location is a different entity from a strategic standpoint than an asset itself. The operating location may have multiple assets rotate through it. It may be connected up to multiple networks outside of just the geographic location. It may be connected to utilities, power, water, waste, IT networks, those types of things, where we want to understand the interrelationship between all these different assets out on the plant floor. If we're going to turn off an electric panel for an overhaul of some sort, we need to know all the assets connected to it. We need the ability to track all of that as we inventory our assets. Another major thing that we need to look at to really accelerate understanding our assets is that these assets do move from time to time in most organizations. There's different terminology people use to identify assets that have a tendency to relocate themselves now and then. Repairable spares. If a motor on a pump in a refinery goes out, the refinery manager doesn't want to watch somebody rewind that motor. They want to have that motor out of there as quickly as possible, put a replacement in from inventory, and get that pump back up and running so that the oil keeps moving. Meanwhile, that broken motor can go off to a repair shop, internal or external, and be repaired, and then be put back into that store's inventory for a future application anywhere in the plant that requires that type of motor, that size, those types of things. So we need to keep track of all of that. The key to doing that is we set up an item master record. We define that item as indicative of assets that are being acquired, issued, installed, maintained, and then every instance of that item number that comes in will be assigned an asset number in the system. So we can now keep track of all the work that was performed at any location and determine if we've got a fundamental problem with how that location is architected. We can also keep track of all the work performed on a specific asset, regardless of where it was over its life cycle while we owned it. And that gives us a lot better insight into where we have problems that we need to systemically research. Now, from there, once we've got a good inventory of our assets and we know where they are and what details about them are available, we need to prioritize the asset management strategy. Basic fundamental fact is assets degrade over time. You can debate that all day long, but the bottom line is when you put something in use, eventually it's going to wear, it's going to degrade, and its uptime is going to diminish. And again, our focus is keeping that uptime going. So how do we maintain and monitor those assets in such a way that we can make sure that those that are most important are the ones we're paying attention to the most? And I've got a proposed prioritization process here on the screen that you're welcome to adopt, refine, and extend as appropriate. We start out with the most critical assets. We'll give them 5 points on the scale. Those require intensive management, monitoring, real-time systems, up to and including an individual watching screens that monitor many of these assets all day long. The goal here is to completely eliminate downtime. They're very critical to either a manufacturing process, an oil and gas process, life support processes. No downtime. We need to be intensively managing these assets. We have other assets that are just about as important, very expensive to repair. Monitoring may be in place for it to some degree, but it's not a catastrophe, it goes down. So we don't have to everything be a priority 5 critical asset. From there, we've got routine assets. assets that we definitely want to maintain. We want to do some preventive maintenance, do some inspections. No sense just letting them run to failure because they are kind of important to what we do. But there are assets, it is actually a valid classification prioritization to say that there are assets we're just going to run to failure. The cost to maintain exceeds the cost to replace. Or it's an asset that we know is at nearing its end of life. We're going to run it till it runs out, and then we're going to dispose of it. And then the lowest priority are those assets that are designated as headed for disposal, either in a storage location or still in a processing location, but we know that those are not going to require, or we're not going to perform any maintenance on those. So we want to be cognizant of what that maintenance strategy is. I want to talk briefly about those asset management and monitoring technologies that are now available. More and more assets that are purchased, whether it be for your home or for a major manufacturing facility, they're all IP addressable. They've all got data that they're spewing out in one form or another. For decades, people have installed SCADA systems to get system-wide visibility. Your water system, there are pumps and monitors and sensors all over the entire system to monitor the pressure through all the water pipes throughout the entire environment. That's all on an isolated network more often than not, but that information can be used to identify where there's leaks. If all of a sudden the pressure is out of line. Your HVAC system in large buildings has sensors on either side of all of the air handling units, and if the pressure differential goes out of tolerances, we need to do work on that. Vehicles, trucks and cars have telemetry. Most of today's semis have large telemetry capabilities where they can spew out hundreds of different variables real time that can be gathered and collected up to monitor the engine performance, report that back to Cummins or to the owner, and identify when maintenance is required to keep things operating efficiently. There are also very detailed, almost micro level asset class capabilities that are used to inspect assets. Pavement, for example. The roads department can drive down the road with a camera mounted on the front of a vehicle and identify where there's problems and what the condition of the road is and when it needs to be resurfaced or replaced. Rail geometry. There are rail cars that every passenger rail system puts out, or uses, I should say, that goes out and literally will run down the rail and find out where there are dips that it's causing the cars to sway back and forth. Because the more of the swaying back and forth it does, the higher the chances that it'll break the rail. So we need to adjust the rail so that we don't have those problems. Meter readings can be gathered manually or electronically. You can do oil color analysis, thermal analysis, and nowadays we've got all sorts of new capabilities on visual inspections that can be done in an automated fashion as well. So these types of technologies are applicable to those priority 5 and 4, the critical and important assets that we need to have a real-time information about how we're going to monitor those assets. From there, need a maintenance plan. So we need to define the data captured that's necessary to track that degradation, and then respond to that recommended work plan for possible situations, whether that be a preventive maintenance or corrective or an emergency situation. What's in the work plan? Pretty straightforward. For PM, it's an inspection. It may include some basic repair of wear out. So your car, if it still has an internal combustion engine, has routine maintenance of an oil change. So that includes taking the oil out, replacing the filter, replacing the gasket if necessary, plugging it all back in, checking all the levels, and putting the car back in service. If there are issues identified, they should be classified as a follow-up work order or corrective maintenance. The next type of work that's included is corrective. From there, we can identify that in the event of a particular failure, again, going back to your car, the manufacturers publish a huge library of work plans and the labor estimates associated with it and the tasks to figure out how to do the repair to fix what's not working correctly. And then planned overhauls are also part of it. If you're going to take that motor offline and rebuild it, what exactly are the steps that are entailed? And what parts do you need? What tools do you need? And how much time is it going to take? That can all be part of your work plan. One of the keys to the more efficient planning is standardize your plans across broad groups of assets. So we don't need to go write out a job plan for every individual asset. We can look at the class of assets, look at that item number, and define a PM plan, and then apply it to that large class of assets. Sometimes a single PM plan can affect 1,000 different assets in the field, and a change to that PM will require a lot of approvals because of its impact. Other types of work that are going to happen are predictive maintenance. We can monitor all of those sensors and see that over time we have a trend that something's going up or down when it shouldn't. So we can predict in advance, sometimes well in advance, when that trend line is going to cross a threshold that we don't want to see. So we can say, based on the prediction of 3 months from now, this asset's going to start to have problems. What's the lead time to get the replacement asset in and to put in place all the things we need to do to replace it before it breaks? Planned work is also a significant part of most maintenance and engineering organizations. Renovations, additions, replacements, rehabs, projects, they can all use the same set of tools to plan and schedule work against the same resource pool. And then there's unfortunately always emergency work. When something catastrophically breaks, how are we going to react? And what types of resources are going to be required to get things back online? What's in a job plan? Start with the tasks, detailed step-by-step of what work needs to be done. Sometimes those tasks require what's called flow control. That means that you need to sign off on each individual step and validate that it's completed before you can go on to the next step. So it can get fairly detailed on exactly what needs to be done. Planned labor. We can identify the crew type or the craft or skill required to perform the work. You don't want to identify the individual because you may have a lot of people who have that skill and you want to balance your resources effectively across a lot of different work. The materials required to do the work from your inventory stores or in some cases custom ordered just for that particular work. The item number and quantity is what it comes down to. Outside services, if you expect to use contractors to do some portion of the work. And then tools. There are specialty tools of which you may not have too many. You need to make sure you've got enough of them available. You've got large equipment that oftentimes has to be charged back to the work order. And again, you need to make a reservation for that road grader to do your project because you've only got 2 of them. So make sure you've got the right number of them before you start digging up the road and those types of things. And then once you implement the plan and start doing the work, you want to capture the actuals against each of those categories. So what tasks got done? Are there any observations or measurements that need to be logged into the system? How long did it actually take? Your labor by craft or individual, by crew, spread across a lot of people, the hours, the type of work they were doing, the premium time that may be affected, those types of things all need to be captured on the work. The actual materials consumed, may not use everything that was issued out to the work order, so you have to return those back, but we want to know what was consumed out of inventory and the receipts from items that were directly charged to the work order. Your hours of utilization on the tools, and then a major part of what you want to capture and monitor in your maintenance plan is what we call failure reporting. Now the goal in failure reporting is for each asset class, identify the class, the types of problems that come up in that class of assets, for each of those problems, what causes those issues, and then the remediation plan for each one of them. So problem, cause, and remedy. The remedy is what work is going to be performed because you had that particular issue come up, and now we need to capture all that information. Why do we want to do that? First off, we need to be able to analyze our maintenance program. The way I like to describe it is we want to put out a histogram of those problem, cause, and remedies, and where we see the same problem or cause or remedy coming up very frequently, then we need to go back to engineering and say, hey, we don't have the right assets here, or we don't have the right architecture. We need to do something different to cut down on the frequency of our failures in these particular class of assets. We can also use this to evaluate, are we doing too much corrective? Maybe we should do some more preventive, or the inverse. We're doing all this preventive maintenance. We're not finding any problems during any of our PM inspections. Rather than every 30 days, let's bump it out to every 45 or 60 days and see if we still have just as good of results. and cut down our costs a little bit. Some estimates are as high as 60% of all preventive maintenance is not necessary. So we want to be able to analyze that with the data we capture. Too much downtime, maybe we need to do more PMs. Labor effectiveness, how much time are people actually spending doing work? In many industries, bane of their existence is what they call windshield time. The amount of time their technicians and crews are driving out to a location to actually do work. So is there a way we can minimize that by reorganizing the schedule and plan for works to cut down on windshield time? I've worked with customers that have analyzed their labor effectiveness to be under 50%. What's causing them to spend more time, and what can we do to improve their effectiveness? Those types of things. And then quality assurance checks. Just because somebody recorded on a work order that it was done, are we checking that we are accurately doing the work properly, or are we just checking off boxes so that we can go on to the next activity? What this results in is a maturity model that really says some organizations, many in fact, start out with just, hey, if something needs to be done, I send somebody else to do it. We need to improve that maturity. We need to move from just responding to being aware of the fact that we need to be more proactive, to understanding where our challenges are and what we're doing to affect them and change them, to getting very competent at maintaining our assets, and to getting up to an excellence program. That's where your reliability-centered maintenance comes in, and that's where our Banetti team is very focused. It's helping our customers move to that effective maintenance program to where the assets are working efficiently, and the asset maintenance program is no longer considered an expense that's a drag on the numbers, but it's an investment that accelerates the performance of the organization. There will be a lot of advanced topics that are available in this. I'm just trying to run through the basics of an asset management strategy. RCM, failure modes and effects analysis, the failure modes, effects, and criticality analysis, doing root cause analysis, business intelligence and analytics. There are a lot of tools that are in the market and a lot of approaches to doing maintenance management to really take organizations up to that next level to where they've got an effectively running operation. Thank you very much for your time, and I look forward to talking to you again as we move into the next section of this 4-part series.